अस्सलाम वालेकुम डियर स्टूडेंट्स, मैं हूं इशफाक रियाज और आज हमने आपके लिए एक और इम्पॉर्टेंट और इंटरेस्टिंग टॉपिक लाया है। ये एक्चुअली है डायमेंशंस एंड डायमेंशनल एनालिसिस और इसके एप्लीकेशंस। हमने ऑलरेडी 4 एप्लीकेशंस डायमेंशनल एनालिसिस के पढ़े हैं एंड टुडे वी विल बी डिस्कसिंग द लास्ट एप्लीकेशन ऑफ डायमेंशनल एनालिसिस, दैट इज हाउ टू फाइंड dimensions of constants in a relation. So far we have discussed how to check the accuracy of a given physical relation, how to recapitulate forgotten formula, how to convert one system of units into another system, and today we will be discussing how to find dimensions of constants in a relationship by simply using the principle of homogeneity of dimensions. Dear students, आपको याद होगा what is the statement of principle of homogeneity of dimensions? The dimensions of each and every term on either side of the relation must be same. For example, if this is m power a, l power b, t power c on LHS, and on RHS if we have, suppose this is m power x, l power y, t power z, then by the principle of homogeneity of dimensions, a must be equal to x, b must be equal to y, and c must be equal to z. So this is basically the statement of principle of homogeneity of dimensions, that is dimensions of each and every term on either side of the relation must be same. So I will be using that principle of homogeneity of dimensions in this very application. And one thing more, ये वाली application जो है dimensional analysis की, it is based upon the fact that only the quantities of same nature, क्या कहा मैंने, only the quantities of same nature can be added as well as subtracted. बात समझ आ रही है ना? So in physics, only the quantities of same kind of same nature can be added as well as subtracted. What does this mean? This simply means that force can be added to force alone and force can be subtracted from force alone. You are getting my point? So force plus force is force and force minus force is force. So I will use this principle to find dimensions of constants in a relation by simply using this very application of dimensional analysis. So let me illustrate this very application, this very use of the dimensional analysis by the help of an illustration. बात समझ आ रही है ना? तो suppose x is equal to at square plus bt cube, where x is distance, it is measured in meters, and t is time period which is measured in seconds. हमारे पास एक relation है, x is in meters, t is in seconds, and we are supposed to find the dimensions of a and b. बात समझ आ रही है ना? तो as I said earlier, only the quantities of same nature can be added as well as subtracted. So x here represents distance or displacement, time this t. So it is 80 square, let this be bt cube. बात समझ आ रही है ना? So x here represents distance and t represents time. Let's try to find out the dimensions of a and b. तो कैसे निकालेंगे? तो अभी मैंने जो प्रिंसिपल आपको कहा, ये जो 80 square है, ठीक है ना? बात समझ आ रही है ना? It must have same dimensional formula as that of x. ठीक है ना? तो x की जो डायमेंशनल फार्मूला है, so what is x basically? It is distance or displacement, so it is simply represented by L. You are getting my point? So 80 square must have the dimensional formula of L, right? Now we are supposed to find out the dimensional formula of A, that is simply equal to L divided by T square. So this is simply represented by L, and how do we represent the time in terms of dimensions? Simply by t, so this is t power 2. You are getting it? So the dimensional formula of A will be simply Lt power minus 2. This is how do we find the dimensional formula of a constant in a relation. So far we have found the dimensional formula of A. Now let's try to find out the dimensional formula of B. See, so bt cube, it should have the same dimensional formula as that of x. Now B must have the dimensional formula of x by d2. This is basically the application of dimensions and dimensional analysis. Now, let's try to find out the dimensional formula of B, that is another constant in this very relation. So, what is the dimensional formula of x? We represent it by L. And what about the dimensional formula of T cube? We represent it by t power 3. So, let's simplify it a little bit, and I will get the dimensional formula of B, that is simply L t power minus 3. So this is the dimensional formula of B and this is the dimensional formula of A. Now let's try to write the SI unit of A from this relation. So let me write the SI unit of A from this relation. So L we represent it by meter and time. So this is meter per second square. It will be the SI unit of A, and from this very dimensional formula, let's write the SI unit of B. So this will be simply meter per second cube. You are getting it? So this is how do we find the dimensions of constants in a relation, by simply using the principle of homogeneity of dimensions and the fact that dimensions, rather only the quantities of same nature can be added as well as subtracted. Now let's try to illustrate it with the help of one more example. I will be finding out the dimensions of, let me write here, van der Waals equation. So this will be the illustration second for this expression. So let me write here van der Waals equation. ठीक है ना? तो van der Waals equation क्या है? P plus A by V square into V minus B, it is equal to RT. This is van der Waals equation for 1 mole of a gas. Now the question is, we are supposed to find out the dimensional formula of A and B from van der Waals relationship. Now as I said earlier, so P represents here pressure, V represents volume, R is the universal gas constant, and T is the absolute temperature. You are getting it? You are following the steps? Now let's try to find out the dimensional formula. First let me find out the dimensional formula of B. Now as I said earlier, volume can be added to volume alone and volume can be subtracted from volume alone. So dimensional formula of B is same as that of dimensional formula of B. So B must have the dimensional formula of volume. Now the question is, what is the dimensional formula of volume? It is simply L power 3. So what will be the SI unit of volume? This B here, it will be simply meter cube. You got it? So volume can be subtracted from volume alone. So B must have the dimensional formula B. Now, as I said earlier, this is pressure here and A by V square. So it also must have the dimensions of pressure. So A by V square must have the dimensional formula of pressure. बात समझ आ रही है ना? तो A की जो dimensional formula है ना, dimensional formula of A, it will be equal to dimensional formula of PV square. Now pressure की dimensional formula हम निकालेंगे यहाँ. Pressure is basically force per unit area. तो force is mLT power minus 2. Area is L power 2. एक cancel हो जाएगा. So this is m L power minus 1 T power minus 2. This is the dimensional formula of pressure. Now let's try to find out the dimensional formula of A. So this will be simply the dimensional formula of pressure. What is that? So pressure की जो dimensional formula है वो है m L power minus 1 T power minus 2. What is the dimensional formula of volume? It is L power 3 और इसका स्क्वायर है. ठीक है? तो मैं इसको हम ऐसे सिंपलीफाई करेंगे. m L power minus 1 T power minus 2 और यहाँ पे आ जाएगा L power 6. So let me simplify it. So this is m L power 5 because 6 minus 1 is 5. So this is T power minus 2. So we have found the dimensional formula of A as well as the dimensional formula of B. So let me write here the unit of A. ठीक है? So let me write here the SI unit of A. So this is basically kg m power 5 per second square. So dimensional formula of constants in a relation. Only the quantities of the same nature can be added as well as subtracted. So this was the dimensional formula of A and B in van der Waals equation. ठीक है ना? तो दो एग्जांपल मैंने आपको दी to find dimensions of constants in a relation. Now एक और एग्जांपल मैं आपको देना चाहूंगा. So let's try to illustrate this very use or this very application by this example. ठीक है ना? हमारे पास एक relation है, इसको हम कहते हैं Cauchy's relation. How this is basically the refractive index of a medium. So it is basically equal to A plus B by lambda square. बात समझ आ रही है ना? Where A and B are constants, mu is the refractive index of the medium and lambda is the wavelength. ठीक है? तो हमें डायमेंशनल फार्मूला A और B निकालनी है. ठीक है? नाउ as I said earlier, ये जो refractive index है, what is it equal? It is basically the ratio of C by V. What is C? Velocity of light in vacuum. What is V? It is the velocity of light in the medium. So it is velocity by velocity. So refractive index is, as you already know, it is a dimensionless quantity. ठीक है ना? So it is also unitless quantity now, as I said earlier. So mu and A, it must have same dimensional formula. ठीक है? तो dimensional formula of A, it must have same dimensions as that of mu. So this will be simply m power 0, l power 0, t power 0. I mean ये जो A है constant है, it must be dimensionless. और एक और quantity है यहाँ पे b by lambda square, it also must be dimensionless. तो इसकी जो dimensional formula है m power 0, l power 0, t power 0. तो what does this mean? ये जो b है, it must have the dimensions of lambda square. What is lambda? It is the wavelength of the light. Now let me write here the dimensional formula of b. So this is simply equal to wavelength की dimensional formula क्या है? L. Since we have square here, and I got simply L power 2. So this was the third illustration. How do we find dimensions of constants in a relation? I simply used the fact that only the quantities of the same nature can be added as well as subtracted. So force can be added to force alone. I mean force plus force is force here, and force minus force is again force. So this was all for today's lecture. Hope you understood it very well. I will be meeting you in the next lecture. Till then, Khuda Hafiz.